We're here in our laser lab. We want to show you how to make femtojoule measurements with our PE3B silicon joule meter and M-LINK. We're set up here in front of our YELF laser. We have some ND filters to attenuate the laser. I placed an ND4 filter on the front of the probe to cut down background light, including fluorescence. We've got the laser running with it attenuated right now at about 500 femtojoules. The M-LINK is set up with an external trigger from the laser and an analog output to the scope. Let's take a closer look at the probe output on the oscilloscope. So you can see on the oscilloscope we've got a very clean voltage output from the probe at about 1 volt, very stable. Obviously at 500 femtojoules this is going to be an easy thing to measure. Let's look at the software now. We've got the instrument set up in the internal trigger mode, a 2% trigger level. We're reading about 535 femtojoules with a RMS stability of less than 1%. Not an issue. Now let's go back and attenuate the laser down to the 10 to 20 femtojoule range and look at this voltage output and the instrument software again. So we've attenuated the laser down to about 20 femtojoules. You can see that the analog output from the probe is very unstable and noisy. There is the laser pulse. Now let's take a look at the software. We have the instrument set on internal right now. It's measuring about 25 femtojoules, but the rep rate is very unstable. And the standard deviation for a data set, the RMS stability is about 12%. Now let's engage the external trigger feature. Take another data set. We're getting a good solid rep rate now, of course. We're reading about 19 femtojoules, but the RMS stability is still poor at 21%. So now we'll take advantage of the unique noise suppression feature of the software. I'm picking 128 pulses. I'm going to take a data set, and you'll see now we're reading 17 femtojoules with 0.636 RMS stability. If we take another data set, you'll see something very similar, 17 femtojoules and about 1% RMS stability. This can only be achieved at this energy level using external trigger and this unique noise suppression feature. To summarize, you need to use one of our PE3B SI probes mated to our digital joule meter M-LINK using the external trigger. You need to set the software up for an external trigger and engage our noise suppression software set to 128 pulses. And you need to make sure that you've eliminated all the background light in your test measurement setup.